and welcome to my channel. Let's see this problem, Specuial Triplets from August Challenge 2021. So according to this problem, Jintoki has to solve for three integers, that is a, b and c, according to these three equations. The first one is a mod b should be equal to c. So from this equation we can derive that c should be absolutely less than b. The second equation is b mod c should be equal to 0. So from this equation we can derive that b should be a multiple of c. The third equation is that a, b and c should be between 1 and n inclusively. Now let's understand the question with the help of an example. Let's take that n is equal to 4. So first of all we'll try for c equal to 1. For c equal to 1, let's first of all try b equal to 2, because b should be greater than c and b should be a multiple of c. So we know that a mod b should be equal to c. So the smallest a that we can take is 1, because 1 mod 2 will be equal to 1. Then after that we can take a equal to 1 plus 2. And after that we can take a equal to 1 plus 2 plus 2. So we are filling it according to this equation, that a mod b should be equal to c. So we are filling it up for all the a's where we get the remainder equal to 1. Similarly, the next one would be this, and so on. Now let's try for c equal to 1 and b equal to 3. The first one, the smallest a that we can take in our question is 1, because 1 mod 3 is equal to 1. Then followed by that we can take the next a to be 1 plus 3. Similarly, the next one would be 1 plus 3 plus 3, and so on. Let's take 1 is c equal to 1, b equal to 4. First one would be 1, second would be 1 plus 4, third would be 1 plus 4, and so on. Now since in our example n is only equal to 4, and for 1 we have exhausted all numbers till 4. So now let's switch to c equal to 2. For 2, b should be greater than c and b should be a multiple of 2. So the first one that we can take is 4, and a that we can take here is 2. Why? Because 2 mod 4 is equal to 2. But there is something that we need to consider. As we can see that a should be less than or equal to n, we need to find out how many a's we can take for the given c and b. So let's find out number of a's for given b and c. So we know that 1 plus 2 into x, let's take this number to be x. So we know that 1 plus 2 into x should be less than or equal to n. So on solving this, we get that x should be less than or equal to n minus 1 divided by 2. Now the number of a's that we can take for given b and c is equal to 1 plus x. So this small x is equal to, let's take this, let's take it to be y. Okay, so this is y and y is equal to 1 plus x. Similarly, in this case, we know that 1 plus 3 into x should be less than or equal to n. We get x should be less than or equal to n minus 1 divided by 3, and we get y is equal to 1 plus x. In this case, similarly, we get x should be less than or equal to n minus 1 divided by 4, and y is equal to 1 plus x. In this case, we get x should be less than or equal to n minus 2 divided by 4, and y is equal to 1 plus x. We can clearly derive that in a general case, x is less than equal to n minus c divided by b. Now let's see the code. So first of all, we include IOStream. We include standard namespace. We define the main function. We return 0 from it, and the first thing that we need to take care over here is that we take the input of key test cases, then for each test case we have to take the input of n. Then first of all, we'll take c to be equal to 1, and then we run c to n and c++. And inside this loop, we take b to be the first multiple of c, that is twice of c, and b should be less than equal to n, and b plus equal to c. Let's take our answer in this variable and initialize it to 0, and then we will add answer plus equal to 1 plus n minus 1 divided by, sorry, n minus c divided by b. Okay, I think that should be the solution. Let's try to submit it. So let's try to submit our solution. Okay, it's showing wrong answer. Oh, I forgot to print the answer. Let's try to submit it again. So the solution got accepted, and thanks for watching.